In this video, we'll take a look at some examples of problems that use differential equations in them. This one is from an actual AP exam. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. That sounds like a lot. Just bear with it, keep reading. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird, that's big. They gave you a variable here. In our last few videos, we had to figure that out for ourselves, but here they helped us. B of t is the weight of the bird in grams at any time t days after its first weight. So those are our two variables. We've got b is the weight, t is the time, and that means that dB dt is the rate of change of the weight. And they tell us that dB dt is 1/5 times 100 minus b. The 100, by the way, in this case, seems to be the adult weight. That wasn't a very helpful font. Seems to be the adult weight of the bird. So the rate of change is proportional, it's some constant, times, not the weight itself, but the difference between the bird's adult weight and the current weight. That's what the 100 minus b is. Okay, so we're going to look at parts A and C. We'll skip over part B. Maybe we'll come back to it later in the year. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Well, it's asking us for two things right now. If we want to know whether the bird is gaining weight faster at one moment or the other, we just want to know at what rate is the bird gaining weight at each of those times. It is asking us for dB dt evaluated at b equals 40 and dB dt evaluated at b equals 70. That's what it's asking us. So we can simply plug those in. Plug in those two values for b. 1/5 times 100 minus 40. 1/5 of 60 is 12. And 1/5 of 100 minus 70 is 6. So since the rate at which the bird is gaining weight is bigger when b is 40, we can say the bird is gaining weight faster. When it weighs 40 grams, sorry. And if that seems a little bit easier to you, it's supposed to be a little bit easier. If the question is just asking, it's just trying to make sure you understand what these words mean, what these dB dt, the rate of change, what it all means, and applying it to the real world question. It did ask for an explanation. It didn't just say justify, it said explain, so it is going to look for words here. So we would say, because dB dt is higher at b equals 40. That's not an explanation. Okay, that's just the little sideshow. The main event here is part C, where it asks for the separation of variables. And I'm not sure how easy it is for you to read it on your screen, but I do have the solutions manual, the solutions guide here also, so I could show you the point breakdown. It's a little bit hard for you to see, but part C is worth 5 points. Parts A and B are each worth only 2. I don't actually even have A on here. So you can see that this idea of the solving the differential equations, what it's asking you for in part C, is very important. Use separation of variables. That was very nice of them to tell you that. They won't always say that. Sometimes they'll expect you to know that on your own. To find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. That sounds fancier than it really is. It's just saying solve the differential equation. So we'll start with the differential equation dB dt equals 1/5 times 100 minus b. And then to solve that, they already told us we need to remember to separate the variables. They told us to do it. We just have to remember what that means. It means move all the b's and db's together, move all the t's and dt's together. In this case, there's not a lot to do there. We'll have to move the 100 minus b to the left-hand side, and we'll move the dt to the right-hand side. If you really want to, you can move the 1/5. If you'd rather see it as a 5 on the other side, you can. I don't think it's easier that way, but you can do it if you like. And then we need to start solving that. So our next step is to integrate both pieces. And so be careful about this one. I'm going to write something down, which is probably the first thing you thought. And then take a quick look at it and tell me what I missed. I'm going to first rewrite this so it looks a little bit neater. Okay, did you catch what I missed? I said that the antiderivative of dB over 100 minus b is the ln of the absolute value of 100 minus b, but chain rule, there's a minus sign in there, and that makes a big difference. So you do need to put that minus sign in front. Okay, and then our job is to solve for b. You have the option of deciding whether you want to solve for the constant of integration now or later. If you look at the solutions manual, they do it now. Though, to be honest, I don't think it's really easier now. It's up to you. Just to show you what they did, I can actually make it a little bit bigger so you can see what they did to solve the constant of integration now. This is the step where we are. And then the next thing they do, you can ignore the next line, is they plug in the b and the t from the initial condition, the t of 0 and the b of 20, to find the value for c. So we can do that. We can go with that. If you didn't do it until later, it would work also. But using that, we can say that c equals the negative ln of 80. That's really my c. I had called it c1, but I never actually changed it, so I'll just call it c. So then we can write that in here. Negative ln of 100 minus b equals 1/5 t minus the ln of 80. And then you can use your properties of logs that you learned in Algebra 2 and Pre-Calc. Move the ln of 80 to the other side. Ln of 80 minus the ln of the absolute value of 100 minus b. By the way, this note here is a little bit helpful in this case. They do tell us to ignore the absolute value, which we can do. In fact, I'll just rewrite this without the absolute value. Because b can't be bigger than 100, 100 minus b is always going to be positive. So the absolute value of 100 minus b is always going to be the same thing as 100 minus b. I'm not sure if this makes it easier or not to do the logs this way, but I can put the logs into a single, condense them into a single log. So that way when I exponentiate both sides, I'm canceling out all the ln's at once. So 80 over 100 minus b equals e to the 1/5 t. And then we want to get the b by itself, so we're going to switch places with the e to the 1/5 t. And then just manipulate things a little bit to get the b alone and positive. I'll say b is equal to 100 minus 80 over e to the 1/5 t. And that would be how we write the final answer. Notice how in the solutions manual they wrote that a little bit differently, but it's equivalent, so they're both correct. I want you to take a quick look at the scoring guide here. This was, again, I mentioned this earlier, a 5-point part, which is a lot. These differential equation problems are always worth 5 points or so, sometimes 4, but usually 5. And they're almost always broken down scoring-wise the same way. And this is what I really want to highlight to you. 0 out of 5 points if no separation of variables, which means you can get a correct answer, but if you didn't do it the way they told you to, by separating variables and solving a differential equation, they will not give you credit for it. So do make sure you do it. Also, you lose a lot of points, 3 points, if you forget about that c. If you don't remember to use that plus c and then solve for it later, you can't get, even if you figure out what the constant should be and you somehow get b by itself, if you didn't put the plus c and do it in a proper way, they won't give you credit for it. So make sure you're remembering those two things, that you always have to separate your variables and that you have to remember the plus c, so that way you can apply the initial condition and use that to find the equation for just b.